Two, three. Okay. Good morning, everyone, and good afternoon to people joining us from Malaysia. This is the Kubernetes Penang Meetup group, where we are having two community members back from India who will be talking about cloud native chaos engineering. So, along with me, I have Prithviraj and Sain Mondal, who are the community members for Kubernetes Chaos Engineering Meetup back in India. And they will be giving us an introduction about what is chaos engineering, and especially from Prithviraj. And later on, Sain will be talking about running your chaos experiments using chaos. And later on, we'll switch to the Dr. Penang Meetups edition, where I will be taking the control and we will be talking about the new desktop features which has been released lately by Docker and its integration with Amazon ECS. So, giving the control back to Prithvi. Prithvi, it's all stage is yours.
Thanks, Ajay, and welcome everyone. Welcome to this meetup today. Good morning, good afternoon. My name is Prithvi Raj, and I am the community manager for Litmus Chaos. I also work as a CNCF meetup organizer for the Kubernetes Chaos Engineering Meetup. And probably I'll just share my screen. So, Jay, are we sharing?
Yep.
Yeah. So before I start, I'll just start off with an overview probably. So I'll be taking you through a journey where I talk about chaos as well as Litmus as a tool set to carry out chaos engineering. A lot of people might be aware of it already, but with this talk, probably I hope that you'll get a lot of insights on what exactly chaos engineering is and how Litmus Chaos can help you out carry out that chaos engineering. So before I start off, I'd just like to give you an example. So, like the festivities in India just ended, and there was a lot going on along with the festivals as well. So, what was that? Basically, the sales, the Great Indian Festival that was brought up by Amazon or the Big Billion Days sale by Flipkart. So, what happened during that time? What changed for Flipkart or Amazon in their systems? The amount of users, the scaling ability of Amazon to, let's say, host 1 million users and 10 million users at a time. It changed, and that was basically a change in the state of the system, or the change in the system. And that is where chaos engineering actually comes into play. Why do I say so? Because chaos engineering is nothing but inducing a different sort of a situation in your system, a situation where your system can behave abruptly or sustain that. So that is where chaos testing comes into play. And there are a lot of testing methods we are using, let's say unit testing and various other methods, but chaos testing is something which is bringing change to the scenario, not only in the Kubernetes world, but overall in the CI/CD pipelines, or in any system. Chaos engineering is must to use. So before I start off with what chaos is, I'll just like to just give a brief overview of what we are going to talk about, and then I'll move on to what chaos engineering exactly is. So moving on, as you know, Litmus Chaos, I work for Litmus Chaos. I'll just give you a brief overview of the project. Litmus Chaos is part of the CNCF sandbox. If you don't know about the CNCF, it's basically an organization which hosts a lot of cloud native projects, and it works for the welfare of the cloud native world. And Litmus Chaos is one of the projects, or one of the two projects part of this CNCF sandbox. It just landed into the sandbox in June, and these are the social media links. We are obviously an open source project, so the whole code is present on GitHub, and then the community present on Slack, of course, and with a reach of more than 400 plus community members. The docs obviously help you out to carry forward your journey or start off your journey. And obviously our social media presence is there on Twitter, dev.to, YouTube. So our mission statement is basically helping Kubernetes SREs and developers in bringing out weaknesses in Kubernetes deployments. Now, why do we stress on weaknesses? Is because obviously resiliency is something which is going to take up the next few years, or the few years of importance, because the paradigm is shifting constantly, and it's very necessary for us to understand how we want to cater to resiliency, how we, and with Kubernetes growing day by day, it's obviously with people shifting from the legacy systems to Kubernetes or to build their applications or deploy their applications. So it's very necessary to think about the weaknesses that can persist in the Kubernetes deployments. Now, again, the contributors for the project, Maya Data, like I am part of Maya Data, of course, and then into it, Amazon, Ring Central, Container Solutions, NetApp, and many more contributors are there. And Chaos Hub is a place where you find the experiments. We'll move to that a bit later on, but this is the link in case you just want to take a look. You can just go to hub.litmuschaos.io and you can find us. So the project status, as you know, like all around the world, we are working out, and approximately a lot of users are using. More than 15,000 operators have been installed, and more than 1 lakh like experiments have been run. So you can see that everyone is adopting Chaos, and everyone is actually joining this journey of using Chaos engineering for themselves. So anyways, now going back to what the agenda on hand, that is talking about Chaos engineering at first. So before that, we have to understand that what's the state of Kubernetes today, or how Kubernetes is actually being adopted. So let's just talk about the Kubernetes adoption. There are these early adopters, and then there are adopters which like adopt it after it comes to the mainstream market. So Kubernetes is somewhere in between, where not everyone in the early market has adopted it, or not everyone in the mainstream market has still moved on to Kubernetes. There are a lot of solutions which are needed, because obviously Kubernetes having a lot of vulnerabilities as well, and everything, we are moving in a very fast world, everything is developing. So there are people who need complete solutions, and then there are people who are attracted by new things. So Kubernetes is somewhere in between. So what is the process to lead to that greater adoption? Obviously, check the resiliency, because as I mentioned, resiliency is gonna bring the next shift, or the paradigm shift. So it's very important for us to check the resiliency and keep it at a desired level. So why resiliency? What is resiliency at first? So resiliency is nothing but your system's ability to take up on like certain outages, or like, and if any sort of fault happens, the system staying afloat is what resilience exactly means. And when we come to examples of resilience or weaknesses, so let's say the first example I'll give you, the first weakness, let's say pod is evicted from a node. That's the first weakness that can come up to a Kubernetes application. So how does resiliency come up, right? Either the pod is rescheduled and dependent, like dependent service is healthy, and then the dependent service slowdowns or turns unhealthy. That's again, that becomes a weakness. So we have to understand what is a resilience here and what is a weakness here. For the second example, the node goes into a not ready state. So how does resiliency come into play? Pod is rescheduled and dependent service is healthy, or again the dependent service slows down. So similarly, we have another exam that is about the memory leak. And these are basic examples of how we can find out resilience or weakness in a system. So what is happening under the like common APIs of Kubernetes? We can see the microservices architecture is developing, and there are so many applications already present, from database applications to streaming and messaging applications. So the microservices architecture, which is being adopted slowly and slowly, is full of a lot of applications. There are various applications, like, and they are developing day by day, which is replacing the like the legacy applications or the monolithic architectures. Now in the DevOps culture, obviously we know that it's very necessary to have a stronger CI/CD, and that is how just because the change in the application is happening so like X so many times faster, while it moves to the end user stage or the staging production stage. It's very necessary to actually like live up to this cloud native environment, or the environment which is moving so fast. So moving on to the on what depends, like on what factors do the resiliency depends. Obviously, there's, let's say I divide the stages into pyramid, and there are various stages. The first stage will be your application, but I would say 90%, more than 90% of the factors which like resiliency depends upon are the other factors. That's, let's say, the database, MongoDB, Kafka, and the applications, the cloud native services that are provided to you, Envoy, Prometheus, Grafana, and in case of Litmus, obviously the sister project OpenEBS also comes into play for the cloud native data management purposes. And then there are the Kubernetes services provided by Kubernetes, and then you have the infrastructure service. So resiliency is not really dependent upon your application, rather it's, it gradually moves like down the pyramid. That's the like below, the more below we go, the more the resiliency dependency increases. So as I said, 90% of the resiliency depends upon the other cloud native components or the part of the infrastructure, but more than your application. So too many applications, as you know, to build a system or to have an architecture, you need a lot of applications, multiple applications working together, and that can affect the resiliency of your system. So what you need to do is constantly validate the resiliency of your system. You need to constantly keep a check upon it. So how do you check your resilience? Obviously, the first stage here is identify the steady state conditions, and then you introduce a fault. And why do you introduce a fault? Because so that you can check that are you able to actually gain back the steady state condition once a fault is introduced. Is the system still stable? And if it's yes, obviously the system is resilient, and if it's no, you find a weakness. And that's what the basic agenda of chaos engineering is, finding the weakness in a system. So basically what chaos engineering is the idea of inducing, or the practice of inducing a fault in your system, so that you can check the resiliency of it. Let's say you carry out a chaos test of deleting a pod in your Kubernetes system, and you try to understand what happens when you delete a pod, and that is induced deliberately, not after the system moves into production, but before it moves into production, so that you can test the vulnerabilities that are present in the system. So chaos engineering is fundamental to increase the resiliency of today's highly dynamic and highly dynamic applications which are driven by the cloud native world. And obviously it's very necessary with the cloud native world having a lot of features, namely being open source. As you know, Litmus is an open source project. Anyone and everyone can contribute to it. And there are other aspects of it, of doing it the cloud native way. The first aspect is obviously declarative in nature. You get the chaos custom resources to manage the chaos, like chaos tests, of course, and using the APIs to orchestrate, schedule, the complex workflow management. It can be done in a very declarative way. The second factor that makes it cloud native is you get chaos ready experiments. So most of them are generic chaos experiments which work well with the Kubernetes applications, and they are readily available for you to get started with your chaos engineering needs. Any generic experiment can help you with your chaos engineering needs. Now you can also create your own experiments. It's very easy. The software development kit is available in Go, Python, and Ansible, and you just have to think about a basic structure. And as a developer or an SRE, you can go ahead and create your own experiment. Lastly, the chaos workflows. So there are very simple chaos workflows as well as complex workflows which you can construct. So you can just use GitOps, and the chaos workflows can help scale your chaos engineering needs. So moving on, I'll just move on to the features, or as you know, that Litmus is a complete framework to find weaknesses in Kubernetes platforms and applications running or Kubernetes, and it uses the principles of cloud native, the way of doing it. So these are the other features. Obviously, I have mentioned about the chaos APIs, and now I move to the chaos hub. So chaos hub is the place where you get all the experiments. There are 37 plus experiments, chaos experiments, which where you can just find how you can which experiment do you need, how do you need it, and which experiment is going to help you. Again, the docs come into play to help you get started with it. But there are various experiments related to the generic chaos or AWS level chaos, infra level chaos. Even for Kafka or core DNS deployments, you do get chaos. And as I mentioned about the chaos SDK, lastly, moving on to the chaos portal. So there's this chaos portal which has come up, which helps Litmus like provide you with capabilities to orchestrate complex workflows and monitor the chaos events, or have a better way of observe and scale your experiments in a very active development mode, having your own development space. So, anyways, these are the basic features of Litmus. The Chaos APIs are backed by Chaos, the Chaos operator, and the experiments are written as custom resources. And obviously, as I mentioned, that you can schedule Chaos in a very declarative manner, so you can schedule any experiment whenever you want with the Chaos scheduler. So let's say I think I'll, if in case you require the demo, feel free to ask. I'll forward the link for the demo as well. And developers and SREs, basically SREs is a concept which is brought in by Google, or people did not actually think about reliability in that way, but then the SRE angle came into play, and SREs today are the ones who are really focusing on reliability and resiliency in the Kubernetes world, and they are the ones who can use it to who can use chaos engineering or the automated chaos experiments in their Kubernetes clusters. Lastly, obviously, the GitOps model is recommended for large teams. Like it varies from team to team, but yeah, chaos management using the GitOps model is going to be really helpful. So I think I have mentioned everything about the chaos hub. So basically, like they are tunable through YAML in a declarative interface. That's the extra point that I would like to bring up, and you can always check the chaos hub for the new experiments that are getting added. And talking about the SDK, obviously SDK is used to create a basic scaffolding required for a new experiment or a new experiment that is necessary. And most of the experiments which are like which were already created in Ansible, they are now also being ported to Go, so that like users can have a better interface or have like multiple aspects of it for themselves. And lastly, chaos logic of your experiment is wrapped into a container image, and that image can be retrieved anytime to induce chaos in your systems. So lastly, moving on to the latest development, that's the portal. I believe that chaos engineering, the experience, or what a user uses, needs to have a better aspect or a better lookout for people using it. So you need to be able to orchestrate the complex chaos workflows using, like, as you know, that the chaos workflows are somehow formed using the chaos experiments plus the flux or argo cd workflows. So these workflows help you monitor your chaos events or the events you're trying to like carry out, and even the metrics around your chaos experiments, the measurements, and how is it working in an active development state, or how easy it is to manage the new experiment among your team or you as an individual as well. So these are the experiments, a few chaos experiments that I'll talk about, or like a few experiments that are very necessary for the Kubernetes world. So these are the few experiments, as you can see: node maintenance or node loss, node drain, node eviction, and then node resource exhaustion, node ungraceful loss, disk loss, DNS service disruption. And the description is here on the screen for you, so you can check it out in I think 30 seconds. So moving on, here's the very generic pod kill or container kill experiments, pod network faults. These are very generic experiments. So these experiments are very necessary for, even if you're starting off with Kubernetes application development, these experiments help you understand where is the vulnerability actually existing. And basically, as you know, chaos engineering is breaking things on purpose to join them. It's basically you break them so that you can actually understand that where the weakness lies, and henceforth whenever your system moves into production or gets started, you don't have to face such sort of a downtime or an outage, because it can lead to a lot of loss. It can lead to loss. Obviously downtime can lead to a lot of loss in time, loss of money as well. People, like, companies lose billions if their system goes down. So that's why these chaos experiments are very very necessary. And for the cloud native world, as I said, there are experiments for the cloud native world as well: OpenEBS, Kafka, Cassandra, Longhorn, Redis. There are a lot of experiments which cater to these cloud native applications as well, and can be used alongside them. So these are the experiments. Every experiment is available in the Chaos Hub. So moving on to the use cases, people, as a DevOps engineer, you might ask, where can you use Litmus? So you can use Litmus anywhere, from the CI pipelines to the pre-production system, or from before the application moves into production, that's in the staging phase, or the pre-production phase, production phase. As a DevOps engineer, in all phases you can use Litmus. Litmus is basically used at the application level layer of things, but that's we are also moving on to bring in chaos tests for the infrastructure and the network layer. But as a DevOps engineer, there's no place that you can't use chaos testing. Chaos testing can come handy at any place you want. So lastly, I think I'll move on to the roadmap. Yeah, 1 second. Unfortunately, I'm not able to have a large screen for this. But yeah, so the project governance, as you might know, that the roadmap is open for everyone. Anyone and everyone can check out how the project is governed. And obviously, to drive a community or to drive an open source project, a lot of things are important. Being part of CNCF, you have to have a lot of people coming up and contributing and moving on with the project. Updates every month is required, so we have those community calls as well. So I think all this is something you can check out. And moving on, just sharing the long term roadmap probably, for folks out here. So the long-term roadmap is obviously with the CNCF landscape developing. It's basically you have to understand that it should be feasible with other projects as well, or other projects can come in and contribute or can be integrated with, to make the user experience easy. So these are a few projects, CNCF projects or cloud native projects which are used. And this is a screenshot of the monitoring and how the Litmus demo works, how you can manage your chaos workflows. So I think this I would have given a demo probably, but I think Cyan will be talking about in depth of it. So I won't take much time. I would just like to conclude that SRE is obviously our persona, or the persona which puts in the inputs as well as the feedback, because SREs are the ones, or the Kubernetes developers, but more on the SRE side, who actually give in inputs, who share their experiences and drive different use cases. And they are the ones, because these projects do need inputs from the SREs. And I think you can see my screen and check out the current team of SREs who are putting in input from various organizations. So I think that's about Litmus Chaos, and that's about the brief introduction to chaos engineering and how Litmus Chaos is driving it. And I hope you like the introduction, and whatever questions you have, feel free to ask me on chat, or we can get in touch after this call as well, after this meetup. So thanks everyone. Thanks Sujoy again for giving me this opportunity, and I think Cyan will be explaining you more. So thanks a lot.
Yep. Thanks, Prithvi. Uh, that was very short and sweet. So, just one question from my side. If I am a new user to Chaos Engineering and I want to get started, uh, I know definitely there are documents on the Litmus site. Can you just, for our users' convenience, can you just paste the chat link to the documentation where, like any new user, how can they get started?
Sure, Sujay. I'll love to do that.
And
I think
maybe you can do a promotion for your meetup group also by sharing the link so that the interested people can join your meetup group.
sure, Sujay, sure. I think one more aspect of getting started with chaos, or getting started easily, is the Catacoda scenarios, which were again like the Litmus Catacoda scenarios, which were again curated by Cyan here. So I think he can touch upon that as well. But I honestly believe that there are a lot of ways a user can get started, from the Catacoda scenarios to the docs to basic videos. I think even videos are very helpful. So it's just that a lot of people are scared, or basically are, not ready to get started with chaos engineering. But in my opinion, I think it's like you have to believe in the chaos first principle, that why start chaos when your system is already had that abrupt situation, or your system has already suffered through an outage. Rather start chaos from now itself as a first principle, before your system moves into production. So yeah, that's from me. Thanks.
Thanks. So now we will switch to science talk, where he will give us some demos around Chaos experiments using Chaos Hub. Simon, the stage is
Yep.
yours.
Thank you. Yeah. Hi, everyone. That was a great talk by Prithvi, and he covered most of the chaos engineering things in quite some details. I'll also probably touch upon it, and my one will be a brief one. But before that, let me share my screen. And my talk will mostly be centered towards chaos with Litmus. Let me share the screen.
Yes.
Is it visible? Okay. So, in this talk, we'll look at three things. The first to begin with is what is chaos engineering? Why should you be interested in it? And the second one is Catacoda, how you can run Litmus chaos experiments, chaos engineering experiments with Litmus on Catacoda. What is Catacoda and how will we run the chaos experiments there? We will take a look at that pretty soon. The third thing which we'll learn is or look at is the Litmus portal UI and how we can run chaos tests or chaos experiments through the UI. So the first thing is how we can do it via a terminal or a cloud environment where we can basically run kubectl commands, and the second is how we can basically replicate the same that sort of experience on the UI. So a little about me. I'm Shan. I am an ST intern at Data, and I primarily work on the Litmus Chaos project, which is also a sandbox project at CNCF. And today I'm gonna speak about chaos engineering with that particular toolset, which is Litmus Chaos. So to begin with, what is chaos engineering, and why should you be interested in it? So this is the Google explanation of it, but I'll tell in a more simpler way. So chaos engineering is basically a way to generate or produce chaos in your application or in your system to break it, basically. So we want to break your system in order to see how strong your system is and how much it can withstand. So doing this generally means why you do it. We do it because if we want to break a system and the system is strong enough, then it can stand back up. So that is one main thing we want to test in a system, that how strong it is, how much withstanding capabilities it has, so that let's say in the future something breaks in your system or someone tries to attack your system, how resilient it can be to come back up. So that is basically a very important test that every big companies like Amazon, Netflix, they all try and do chaos engineering. So Litmus is also a tool set which provides this similar sort of an experience. So now let's jump into CatCoda, what it is, and how will it be beneficial to us in this talk. So CatCoda is basically an interactive learning and training platform. It's mostly tuned in towards software engineers because it has tons of courses like most of the popular course websites. But CatCoda is not just a course website, it's an interactive website where you can basically test out any applications put out by developers like me and you. So if you are having any application that you are using and you want to put it out, then you can basically do so in here. They provide an interactive cloud environment, and in that environment you can run any experiments or any applications like you would normally do in your local system or local terminal. So they provide you a very interactive cloud environment where you can run kubectl, minikube, docker, any other commands that you would normally do. and those will be stored in the form of a shell, and that shell is the course that you're providing. So you can basically go ahead, take a look at the steps that needs to be done, and then you can imitate the same on the right side, which will be the cloud terminal. So you can have a very interactive learning experience with Caracoda. Next thing is scenario. What is a scenario? So in Caracoda, the courses basically are called as a scenario. So a scenario is mostly a guided path to learn a new technology or tool. So just like any course is about learning something, in Caracoda you learn something, you learn a tool or technology, and they're in the form of scenarios. So scenarios are nothing but a step-by-step instruction, a step-by-step guide, basically, onto what to do next, what is the first step, what is the finishing, what to do after this, what you will learn in the next one. So it's generally a combination of all of this together. It's called a scenario. So the scenarios, like I mentioned, are run in pre-configured live environments, which are pretty ready to use, and they generally take about half a minute or a minute to boot up. So once it's booted up, you can basically go ahead and run anything you want. So as of now, Caracoda supports only these technologies which are listed down here. So you have Docker, Kubernetes, GitHub, Jenkins, and a couple of other very famous tools you can see. And I'm pretty sure they will be accommodating more in the coming years. So as of now, these are the only tools that Caracoda supports, and you can feel free to go ahead and make a tutorial or a scenario on any one of them of your own will. So before we jump into looking at the scenario or basically generating a chaos experiment with Litmus on Caracoda, we need to look at a few custom resources in Kubernetes which are required for running the chaos experiment with Litmus. So the three main custom resources that are there are Chaos Engine, Chaos Experiment, and Chaos Results. To tell you all in a very brief way what those three are, is a Chaos Engine is a resource which links any Kubernetes application or a Kubernetes node to a Chaos Experiment. The Chaos Experiment is a group of configuration parameters basically for your Chaos Experiment. So they form a group, a configuration group, which has the configuration which would be required, and they are invoked by the Chaos Engine. Chaos Results is there is a resource basically which is used to hold the results of the chaos experiments that we'll run, and they generally use Prometheus server to store all the metrics. So let's just jump right into the implementation, and next up we'll look at the Caracoda screen and we'll go forward from there. So let me first stop this presentation and bring in the Caracoda screen. So I guess this is it. I can match it up with this one. Yeah. So this is the Caracoda scenario basically, which I'll be talking about as a part one for this talk. So you can even this public link, you can even go ahead and try the scenario for yourself. So the link is caracoda.com/litmusbot, and then you have a /scenario and getting started. This you won't have to give. If you just give caracoda.com/litmusbot, it will automatically reach this one, and then you find a tab or like a card which says start Litmus. You can just click on this to open up this. I already have done so because, like I mentioned before, the cloud environment takes up a little bit of half a minute or a minute to boot up. So if I open up in this panel, you can see the cloud at the right side. This is already opened, so hopefully it won't take much time to boot up. That's why. You can go ahead and skim through the definition of these. What are they? What is Litmus? And these are the three chaos resources, the custom resources that I talked about. You can take a look at them, and why should you use Litmus, and also what will you be learning in this scenario. Of course, I'll be giving you a brief walkthrough as well, so you don't have to take a look at this right now. So let me just quickly go ahead and start the scenario. So as you can see, it says welcome to Litmus. Same reason it already booted up, and that was the primary reason for me opening it up before. So the first thing we're going to do is decide which application we're going to run the chaos against. So to be a very easy example, I wanted to run against Nginx, and we want to deploy the Nginx application first. So the very first thing is I'll check if kubectl and everything is running fine. So I'll just do a config view to see if they're up or not. I spelled kubectl wrong. Kubectl config view. And yeah, it's up and running, so it should not be a problem. So the first thing we need to do is we're going to apply chaos to Nginx. And so we need to deploy the Nginx app first on our default namespace. So if I click on this, it will automatically start the deployment, and deployment has been created. So to begin with, I'm gonna say clearly that we are not running chaos on any particular namespace. In this case, we are going to do it in a default namespace. So that's why running it on a custom namespace is a little bit complicated. Not that much, but we have to create our own namespace first, and then we need to go ahead and change our RBAC and the chaos engine and all the namespace wherever they have been used, basically. So we can definitely open up Vim and try to modify it, but to keep it simple, I am trying everything on a default namespace. So our Nginx application has been deployed. We can go ahead and check if that is running or not, and you can see the Nginx pod is already up and running. Now we'll continue on to the next step. So the next step is to apply the Litmus chaos manifest. Now the litmus chaos operator manifest is required. The reason why is because they install the required service account configurations and the chaos operators, and also the CRDs, basically the custom resources, which are needed to run our chaos experiments. So we need to apply the litmus chaos operator manifest first. So we can do that by clicking on this, and this should happen very quickly. So it created all the different services account, the RBAC, the role binding. So they are RBACs, the three custom resources, as you can see: chaos engine, experiments, and chaos results. Now we can go ahead and verify if the Litmus namespace has been created or not by doing kubectl get namespace, and you'll see Litmus has been added. If you had done it previously, you would not see Litmus there before, but now that we have installed it, we can see Litmus. Let's go ahead and continue to the next step. Now we need to verify if the Litmus installation has been completed or not. Litmus installation, in the sense, we already know the namespace is there, but we need to see if the CRDs and all the other things are present or not. So we can do a get pod minus n litmus, and we'll see the chaos operator is running. We can verify if the CRDs have been installed or not. So we can grab the chaos, and we'll find the three chaos engines experimental results. You can also go ahead and grab chaos for API resources. I'm just going to skip this one. This is a very basic verification, that's why. So let's go ahead and continue. We already know that everything is present, so we don't need to verify it like that. Now we need to install the experiment. So we need to figure out which experiment do we want to apply, like which chaos experiment do we want to apply. And for that, we have a very broad range of experiments. Basically, we can go to chaos hub, and this is the link, hub.litmuschaos.io. And what chaos hub is it's, as the name suggests, it's a hub of chaos experiments. So you'll find tons of different experiments. So right now we have 37 experiments, and all these experiments have proper documentation as well as video explanations. If you want to go ahead and if you want to take a look at how each experiment needs to be performed, what are the exact steps, so you'll find a step-by-step instruction as well as a video too. So the chaos experiment we are going to perform is pod delete. It's going to be a very, very easy experiment. So it's going to be this one, generic pod delete. But still, let me search for pod delete so that I can show you how many pod deletes we have. And we have Cassandra, CodeDNS, generic, and Gate pod delete. So we are going for this generic pod delete. And once we click on this generic pod delete, we'll find an entire entire documentation of the particular chaos experiment. So we have the video, like I said, and then we have all the different steps that are required. So you have to install the chaos experiment, install the RBAC, and the sample chaos engine that is needed to run the chaos experiment, basically. So that's that. We are not going to use this since we already have the instructions in Catcoda. So just for a reference, I opened this up that you can also go ahead and check the different experiments that are there present. So we are going to do pod delete as of now. So the first thing we need to do is install the pod delete, install the chaos experiment that we selected. So we need to install pod delete first, and in order to do it, we need to copy this YAML, copy this kubectl command. So it's kubectl apply -f and then the experiment. So it's generic pod delete /experiment YAML. So once we apply that, we can see that pod delete has been created. It should be some, yeah. So chaos experiment pod delete has been created. Now we can go ahead and verify. We can get the chaos experiment, and we should see pod delete. So the pod delete experiment got created 7 seconds ago. So the chaos experiment hasn't been started yet. We have installed it only. We haven't started the chaos yet. To start the chaos, we would require chaos engine. So we have installed it. We have installed the pod delete. Now we can go ahead and continue to the next step. Now next is installing the RBAC. Now the reason why is we would need a service account to allow Chaos Engine to run experiments in our application namespace. So that's why we need an RBAC YAML, and just because this is the default namespace, we can just go ahead and directly apply this, and this should be fine. In case it was a custom namespace, you would have to like download it and like wget it, and then we need to open it up in Vim and change the namespace to whatever the custom namespace we had created. So this is pretty simple. We can just click on it and it will be applied. So we can see the service account would have been created. There you go, service account pod delete SA, which is service account created, and the other RBAC rule bindings have also been created with it. So we can just simply go ahead and continue. Now the next step is annotation. The reason we need annotation is it's sort of a security measure, and it is also used as a means to reduce the blast radius. So this is a pretty important step that is required before we invoke basically any chaos experiment. So we can go ahead and click on this. This will annotate our application. Then we can continue simply. Now we can check our current pods. This step, why this step is required is we can see the difference between the two when we have what is the current number of pods, and once we apply the chaos, once we run the chaos, how many pods gets created. So we'll have a chaos runner, we'll have multiple pods, we'll see container being created and container being running and completed. Lots of things going to happen. We'll be watching it in a watch step. So we can go ahead and get pods. We'll see there's only one, which is Nginx, which is pretty obvious like we saw before as well. So we have Nginx, which was created 7 minutes ago. Now what we can do is we can run the chaos, and this is the chaos engine. Once we apply the chaos engine, our experiment that we installed will be triggered. So we can apply it. This is the pod delete chaos engine. So chaos engine has been applied, and we installed the pod delete experiment. So the pod delete chaos got triggered. Now the next thing, what we can do is watch the pods, and we can see Nginx chaos runner. This is the runner which is injecting chaos in our application. And now you can see pod delete. This has been started. The chaos has been started. Now this container has been created. It will soon be running. Once it's running, you will find tons of other things as well. So it'll take a little bit of time, since this is first of all a cloud environment. So that is number one. Secondly, the chaos experiments do take up a little bit of time since they spawn up quite some instances. So it will quickly spawn a few more, probably two more. Okay, so now all of them are in running state. We can basically stop this particular watch and clear the console and go to the next step to see the results. Most probably it will be in awaited state. And yeah, the result is in awaiting state. So it's still awaited. The experiment pod delete is currently awaited. Its age is 44 seconds, so the chaos ran for 44 seconds. If I try this again, we can see that the chaos result has passed, and the past is 6 seconds ago. The chaos experiment passed. So your application is pretty resilient. We applied chaos to it. We terminated the pod, but it still got recreated, and your application is good to go. So that's why the chaos passed. So that's that for. Let me just do it once more for confirmation. Yeah, so it passed 34 seconds ago. So that's that. That's how you can basically run chaos. Any chaos experiments, you can go to chaos hub and choose any particular chaos experiment and use Litmus to run chaos in your applications as well and check your application's resiliency. So that's that for the Katacoda scenario. You can basically emulate this entire thing in your own personal terminal. And if I click on continue, the scenario will finish. And then what are the next steps? So the next step are to run the chaos in a custom namespace, obviously, and that will be a little, I'd say 1% extra hard, not more than that. It's very simple, and to create multiple scenarios with imitating other experiments that we have on chaos. This one is just for pod delete. We'll have plenty others as well, which are there in Chaos Hub. So creating scenarios for those. So those are the next steps. And yeah, so that's how we do it via the terminal or via code, via kubectl commands. Now I'm going to show you how you can do it via the UI. And here comes the Litmus portal. So I'm going to bring in the Litmus portal, the Litmus GitHub repository basically, and that's the root of everything. So I can show you the Litmus project as well as the portal. I'm going to go ahead and close this and the Chaos Hub since we don't need it as of now. So yeah, this is the Litmus project. So the URL is github.com/litmus/litmus, and you can find all the different descriptions, details here. I'm going to talk about the portal, and the portal is what handles the UI part of it. So you can run experiments and you can do all sort of thing in portal. So portal gives you much more control over your clusters, over your agents, workflow agents, all sorts of things. But in this talk, we'll particularly look at how you can run the same experience. So you'll get a developer experience of running it on using the kubectl commands, as well as how you can do it in the UI. So this is the part in portal where I'll show you how you can do it via the portal UI. So Litmus portal provides you a console and UI experience for managing, monitoring, and events. So the platforms that it currently supports is Minikube, GKE, Kind, EKS, as well as Octado Cloud. So you can go ahead and try it in any of those. You would obviously require Kubernetes 1.1 or later in order to run any of your applications, any of your chaos experiments or chaos applications, in order to run any of your chaos experiments. So let's jump into the portal. So the portal, what you can do to run the portal is you would find a very nice guide. So basically this is the installation step of applying the K-test manifest. You can try this one, which is the cluster scope, and this is the taken from master. So you would find litmus/master. This is our latest release 1.9. You can go for this, but I would suggest you can go for the cluster scope. You can apply this, and you can basically go ahead to the wiki of the repository and find go to Litmus portal development guide, and you'll find a very nice step-by-step instructions of how you can run what are the prerequisites, how you can run the backend, how you can run the front end, and all sorts of things. So I already have the portal up and running. I'll just bring that in. So because I have this repository cloned in my local system, I would simply go to the code to this repository basically in my local system, and I can basically do an npm start, provided I am in the front end. Yeah, I'm in the front end directory, so I can do an npm start. And this would boot up the local server, which is, yes, I want to run it in a different port. So this will start up the development server, and this should be up and running in about a minute or so. Since this is a development server, dev server takes up a little bit of time sometimes, so we are going to wait for that for a bit. Once the server is up, I can show you the UI of the portal. Okay, so the server is up. We can go ahead and take a look. Yeah, this is the login page of our portal. I'll be logging in as an admin so that I get full privileges over anything I do. Let me log in, and once it logs in, you will see that it has options. It has plenty of options like connecting targets, connecting your clusters. Then you can schedule your own workflow. You can view a predefined. You can schedule a predefined workflow. You can view any workflow, see analytics, You're going to see all of that in just a minute. So this is the welcome screen. So I'm going to start in as a new user. So I'm the administrator because I logged in as an admin. My project name, let's say it can be demo. Continue. My full name is my name. I can continue. The password will be same so that I don't forget. Uh, Continue, and email is, let's say, very basic email. And let's start. Okay, so it sends a request to the backend, which updates the user, and there you go. So I am welcome. I'm being welcomed to this new page, which is the main homepage of the Litmus portal. So from the portal, I can see predefined workflows. I can go ahead and schedule my own workflow. I can see the latest community analytics of how many experiments have been run this week, this year, and there are pretty some survey links and the docs links. In the right side, in the left side, in the sidebar panel, basically, I can go to settings and change my own personal settings. I can change my email address, change my password, and all sorts of things. I can send invite to my teammates. Can manage users, and this would not be present if you are not an admin, but you can go ahead and see your own team. So in the community as well, you can see the community analytics. You can check out the blogs on dev, and that's that. So it's a pretty broad topic. So in this talk, particularly, we're going to look at scheduling the pod delete experiment through the UI. So if I go to workflow, I'll see there's no records available because we have not scheduled any single workflow as of now. I just logged in as a new user, as a new admin user. So I'm going to go back to home and schedule my first workflow. So what I'm going to do is choose an active cluster. At this point, I won't have any since I just logged in, so it should be none. So what I'm going to do is go ahead and create my, wait a minute, so I need to go to targets and I should see my self cluster. Now, the reason I see a self cluster is because we have two different type of clusters. The target cluster can be internal as well as external. So the internal is what is called the self cluster, which is our cluster. The external could be any cluster, so you can provide your own cluster. So if I connect a new target, you would have to apply the manifest. Manifest will be generated for you. You would have to apply the manifest in your Kubernetes, in your cluster console, and then you can, of course, connect your own personal cluster. That is for external clusters. If I go to external, I should not have any since this is just an internal one. So this is already active. So the cluster is active. Now I can go back to home and schedule a workflow. I should be able to see the self cluster, which wasn't previously there. Now that is active, I can select the self cluster, select and continue. Now I have all these different experiments as of now in the Litmus portal. So I can see a pod delete here. So I'm going to go ahead and select the pod delete. So I can edit my workflow name. Right now it's saved as Argo whatever, chaos pod delete 160 something ID. I can go ahead and click on next. I'll be given a YAML file. I can go ahead and take a look at it in a much broader detail. But this is basic YAML that is being generated on any pod delete experiment. And if you go to the bottom, you'll see the chaos engine right up here. So you have the chaos engine kind is a chaos engine, metadata, namespace, spec, and this is a cube system namespace. The app for the app namespace is cube system, has an app label and app kind. You can go ahead and take a much deeper look into this, but I'm going to just go ahead and trust it blindly, and I'm going to go click on next. So this is the pod delete, how much weightage of the experiment do I want to give. I can of course modify it and change it. I'm going to give it 10, which is the full weight. I'm going to schedule the workflow now. So the summary of the workflow is that this is a name that was created at the very first step. The description is it deletes a pod. Scheduling now, it's not a recurring schedule, it's scheduling now, and the adjusted weight is 10. So I can of course go ahead and view the YAML again if I want to change anything at this point, or I can go back and change it or change it from here. So I'm going to finish it. Now this workflow will be scheduled for me. So now you can see the workflows table, which earlier had no records, now has a running workflow. So this is the workflow that was just created. This is another pod delete. This is the same pod delete, I mean. You can go ahead and show the workflow, click on this, and you can get a very graphical view of the entire workflow. So if I click on info, this will toggle the right sidebar will toggle, and you can see the workflow name, the state, the start time, the namespace, and the currently running nodes. So the currently running node, yellow is the node that is currently being running. This color is for pending, and you see another color which is green, which is for successful experiments. Red is for failed experiments or failed nodes or anything. So if this particular node fails, only this will be turned red, and this will be in pending state because it never went through the pipeline. So currently this is the running node. Now the install experiment is running. Okay, succeeded very fast, and now you have run chaos as the running node. So executed nodes is install experiments. Currently running is this one, as well as run chaos is pending, so it's not in the currently running ones. So we'll soon find run chaos as well in the currently running nodes. We are going to wait for it. So this thing's probably take a little bit of time. I can go ahead and probably open up a new terminal where I can do a kubectl get pods minus n litmus, because I want to see it in the litmus namespace. And there you go. I can see the pod delete chaos runner is being created. So run chaos has been created, and that is why it's not showing up as an executed node. So I can go back, and now it's created. So it's done yellow. So I can see run chaos in the running nodes as well as of now. So this is a very nice way of representing, visualizing your experiments. The one which we didn't had in a terminal view. So we can see only the experiments in a very raw format by only watching it. But here we get a much verbose view of the experiment, what's happening, and which nodes is currently running, which fails, which is not. We can also go ahead and check this another thing, which is show the analytics. So I'm going to show you a better view of the analytics once this finishes. So the home page would actually change to something else. So now the home page will give me analytics about one experiment that I ran. So if I run more experiments, the home page will shift accordingly. So it will show me a graph. It will show me basically a graph of how my experiments have been proceeding. So we're going to wait for a few more minutes. So it's been 3 minutes already. It's probably taking up a little bit of time. I can do another check, and yeah, so the pod delete this has been completed. The others are in running phase. We are going to wait for a few minutes. Okay, so the run chaos just got executed, and now you can see run chaos as well as install experiments, the two that are green in the executed nodes. Now reward chaos will be performed. So whatever the chaos has been happening, it will be rewarded back to its original state, and there you go. The entire experiment passed, and we can see its state is succeeded. Start time 5 minutes ago, and end time is just now. So it ran for about 4.8 minutes, which is a little long. It should be around 3 minutes or something, but sometimes it takes up a bit of time. So the cluster is self-cluster. If you had connected an external one, it would have been that, and the namespace is litmus. So that's that. If I click on it, I can see individual node informations. So the node type is pod, the node phase is succeeded, start time is this, and other different details or a particular node. Now I can, if I go to the home page, notice that the home page will be different. So the home page is something like this now. So I have average result. I have the average amount of workflow that I run, which is 1 per week because I only ran 1. This is the sort of a graph which I get. The more I run, the more this will start populating. It's just now I have only ran 1. I am a new admin user, so it's only 1 in this particular graph as of now. So yeah, that's that. I can also go ahead and take a look at the templates. So these are the default templates that are there, and yeah, that's that for this talk. So I hope you guys enjoyed it, and I hope you guys learned a lot about chaos experiments, how you can run it with the litmus portal, without the litmus portal, with the litmus manifest. And yeah, I hope you guys enjoyed, and have a great day.
Thanks, Sai, for that talk. Um, let's wait to check if we have any questions from the chat.
Yeah, sure.
So, just to start from my side, what I saw was that you were running all your experiments locally, right? And the cluster was also running locally for
Yeah.
you, the Kubernetes cluster. And what would it take me to point to an external cluster? How's that going to be possible? Is it something doable from the UI, or
Uh,
I have to do some
Actually, yeah,
custom
to
configuration?
point it to an external cluster, you would need to first apply a manifest. So when you click on connect the target, the UI will give you a kubectl apply
Hmm.
command, which you just have to paste to your cluster console. So whichever service you're using, let's say AWS or GCP or Azure, you can go ahead and paste that, apply that basically kubectl command in your cluster console, and then you can access it directly from your cluster console. So you can either do this with Minikube or any other provider. So we generally use Minikube. So that's how you
Okay.
can yeah, connect your cluster in that sense, and then you can basically pass it on as a active cluster, and then you can move forward with the same approach of choosing any experiment. Whatever you choose will be performed on that particular cluster, which is your cluster in this case.
Okay. So we don't see any questions coming up in the chat, but I'm sure you can reach out to Prithvi and sign at any time. So we have pasted the Slack channel for chaos engineering, which is basically under the Kubernetes uh, Slack organization, I think so. Right?
Yeah,
Yeah.
sure. We would love to attend all the questions on Slack and reply back to them if there are any.
Okay. So once again, thanks Prithvi, thanks San for your valuable time and giving us a brief overview and introduction about chaos engineering. And we would definitely love to have you back on our meetup editions. Uh, thanks for
Thank
once more
you.
time.
Thank you for inviting us over.
Thanks, Vijay. Thanks for inviting us. It's been a pleasure.
Yep. So I think there's a question that came up. That's from Abhishek. Let me bring it up on the screen. And Abhishek has a question. I'm curious to know if a fault happens, then how the application can be healed.
Mm, how the application can be healed. Well, that's, I guess, the fault will appear like the chaos engineering will tell the particular fault that is there. We have to like it's our own. We have to manually change the fault. Like it's like a, like how a linter performs. The linter can only tell you what is the issue. You can go ahead and
Mhm.
fix that issue, and then again try the experiment, and then see if the issue has been resolved or not. The experiment won't heal your system. It will delete your system, and if it's resilient enough, it will auto heal itself. If not, it will tell you what is the exact fault. So you have to manually heal it up. You can use YAML files to change. You can modify your YAML files. So you can apply other manifests to basically modify whatever is the issue that was causing the experiment to fail.
Okay. I think there is kind of a lag behind our stream, what we're talking. So let's wait another couple of minutes so that we can check if there is any other questions or if there is a follow-up question from Abhishek also.
Sure. So also to add to that, while the time we wait. We can also do a kubectl describe command. So the kubectl describe command with the particular pod name, let's say pod delete fails for some reason. So we can even do
Mhm.
a kubectl describe and then the particular namespace where we are running the pod delete experiment, and then the ID basically of the container, or the ID of the whichever experiment or application or the container whichever failed, and we can get a very detailed view of what exactly is the issue. So it will most probably have a very long log which will have the logs generated where you'll find the error that this particular, maybe the service account wasn't connected, or maybe this was the fault. So that gives a very broad details of what exactly is the fault that we need to look up to and change.
Okay. So I don't see any follow-up questions. So thanks once more time,
Thank you.
Prithvi and
If
Time.
you don't have any questions, we can obviously be happy to
Sure.
help out back.
Yep. I will compile it if there is any and forward it to through the Slack or email, and we can get back to it.
Sure. Thank you for having us here.
Yep. Thanks.
Thanks.
You you have,
Yeah.
you can stay back if you love to hear about Docker from me, and if you
Sure.
have something urgent, feel free to drop out, and you can catch up me later in the YouTube stream. Okay. Thanks, Sam.
Thank you.
Uh, so let's switch to now the Docker Penang Meetup group, and let me share my screen. Screen one, share, and then to keep it for some time over here. I'll give a couple of minutes so that some of our community members join us on the live stream. Uh, so the topic for today's is we are talking about some of the new features that got released with the Docker Desktop latest version, which helps you to deploy your workloads directly from your desktop to a particular cloud provider. In this case, it would be either Azure or Amazon. And today we are particularly going to focus especially on Amazon ECS integration with the Docker Desktop. So we'll start in 3 minutes so that most of our members join us on the stream. Okay, so let's get started. Hello, everyone. Um, Good afternoon to people joining from Penang. And we do see members joining us from India also. Welcome to the Docker Penang Meetup edition. Today we are going to talk about some of the new integrations that's been released with the latest Docker desktops and the Amazon ECS integrations particularly. My name is Sujay Pillai. I'm a Docker captain and a community leader for Docker Penang Meetup group. So, for to set the agenda for today's talk, we will briefly talking about what are containers. Then we'll be talking about the overview and features of Amazon ECS, the latest features what are available with Docker Desktop, and do a demo around how to deploy an ECS task manually and how that can be done seamlessly, staying within your Docker CLI and deploying the workloads to Amazon ECS. So, for all those users who are basically joining us for the first time, you might be having a question like, what is container? So if I had to define a container, I can basically say that a container is a unit of software delivery. It is a self-contained piece of software that is packaged and executed with all of its dependencies. Due to this packaging, it's blazingly fast to spin up compared to VMs. The container build process allows you to be flexible. You can declare your customizations when they are built so they don't need to be modified at runtime. Once you have built your Docker image and packaged it as a Docker image, you don't need to change it. So how is that possible? This is all possible due to the tool what we have been using, and it's called the Docker CLI. So basically, when you do install the Docker desktop, you get a command line interface where you can execute your Docker commands. So all you need to do is package your app as a Docker image on your dev box and deploy it into any production, any environment, like it may be your dev stage or prod, without changing any of the artifacts. So in this way, it helps to abstract the complexity of the underlying infrastructure. So all you need to make sure is that the destination where you are trying to run your container, uh, you need to just have the Docker engine installed on it. So the same image what you developed on your machine would run seamlessly on any infrastructure. So that's good when we are running when we were running single containers. But what about running multiple containers? Running a single container or few containers is easy. But what about when we have a fleet of containers to run in our environment? Especially running those applications which has different needs and different life cycle associated with it, and then consider the complexity of managing the infrastructure for it. So you need to figure out a way to run and manage containerized application at scale and continue to use the flexibility a container provides. And also you need to make sure that the platform where you are running this is a secure platform. So that's where we can take the advantage of the Amazon ECS service. So we will now go through basic overview about what Amazon ECS is and what are its different features. Amazon ECS manages the execution of your containerized application in a highly available manner, and it supports the cluster of instances that support your Docker containers and helps you to monitor the resources, its consumption, and the availability requirements. So basically, if you log into your AWS console, you can see leverage the Amazon ECS service, whereby once you have Dockerized your application, build a Docker image, you can push it to Docker Hub, or in case of AWS, you can push it to a registry called Amazon Elastic Container Registry. And then basically you can define your application, what images it would be using, and it gives you a choice to run your workloads on two different launch types. So either you can manually provision the EC2 instances, which are basically VMs, what you provision, have the Docker installed and run your Docker containers on top of it. The second launch type it supports is something called AWS Fargate, which is basically another service provided by AWS, where you don't have to maintain the complexity of maintaining and running the infrastructure to run your workloads. So all you need to do is just pass a Docker image to the Fargate service, and it will take care of managing and running your containers for you. So one is like automatic deployment of your infrastructure, while the Amazon EC2 launch type, you basically say, I want to run my workload on this set of VMs. So that's basically the overview of Amazon ECS. Now let's jump to the benefits that being offered by Amazon ECS. So the first thing is it's elastic. So you can schedule from a single container to thousands of containers. Both the containers and the instances can scale elastically, and it also integrates with other AWS services such as Elastic Load Balancer. It is also manageable. You can define which containers to run and how to run them. It also includes a programmatic API and a dedicated CLI. It's deeply integrated with ECR and other services. So when I say it's integrated with other services, for example, let's say there is a need for your workload to store some persistent information. So in that case, you can make use of the Elastic Block Storage. It's also can be configured to have the elastic load balancer sitting in front of your containers so that it routes the traffic accordingly to specific containers. And the other integration is like we can integrate it with CloudTrail, which is another service provided by AWS, which helps you to capture every API access so that it can be later used for your security analysis, maybe the resource change tracking and other compliance and auditing purposes. And the third benefit is like it's secure. So you can implement granular control over the isolation policies, the availability requirements, and resource allocation. You can also set each cluster in its own VPC. So VPC is like a private network where you isolate your workloads, and then you can use the security groups to control access over your ECS instances. So those were some of the benefits what you can leverage by using Amazon ECS. Now let's see what are the different components of Amazon ECS. So Amazon ECS is basically made up of three basic components that make up the basic infrastructure of ECS. The first is cluster, second is task, and then service. So let's look into each of the component a little bit in depth. So when I say cluster, an Amazon ECS cluster is a logical grouping of container instances for your container workload, which basically runs on the EC2 launch types, and they are spread across multiple availability zones. And if you see the red dotted thing on the screen, those are called the Amazon ECS agent. The agent itself is a container which allows the EC2 instance to talk to the backend logic of Amazon ECS. It allows to have the resource management, the lifecycle coordination, and the efficient scheduling of containers on the EC2 instances. So basically, cluster is the place where you will be running your containers. And then comes the task. So task is where you will group all your container that needs to run on the ECS cluster. Depending on your application needs, we can have a mix of EC2 instance type and place the task accordingly. So for each task, you would basically write a task definition, which is basically you are defining how your container would be running up, what are the different properties associated with. So in my case, if you see on the screen, I'm saying when I run a particular task with this task definition, name that container instances spinning up as Docker Penang demo. Use the image. So this image can be a public image, which is public or private image, which is coming from any registry. It can be Amazon ECR also. So you need to tag the image which you need to use for that particular container workload. And then I'm specifically saying that please allocate 10 CPU units. So that's basically how much resource would be allocated to it. And in terms of memory, I'm saying assign 300 MB of memory. And then there are various settings which are there. So basically, that's a JSON file which you define, and that builds up the task definition for you. So that's how you define a task definition, and which will be used to run your Docker containers in Amazon ECS. Then comes the last piece of the component, which is the service. So service enables you to run and maintain a specified number of instances of the task definition which you saw earlier simultaneously in an ECS cluster. It also helps you to maintain a high availability by making sure that the desired instance of task is running always in the cluster for you at a given point of time. So let's see how we can do all this on the AWS console. So if I have to switch to my AWS console, so I'm already logged into my AWS screen account, and you can search for Elastic Container Service. So as I said, cluster is where your container workloads would be running. So I will basically create a first cluster. And in this case, I'm using EC2 Linux plus networking as the template. Let's go to the next page and fill up the basic details. So Docker Penang demo. So you can use what kind of provisioning model you want. I'm going to use on-demand instances. So there are different options you can choose for your EC2 instance type. Basically choosing leaving everything default over here. I will be using the existing VPC, and let's use one of the existing subnets. So you can also create a new subnet if you want, but I'll be making use of the existing ones, what I have. Let me use the default security group. So security group is where you define how and which traffic should be allowed into your VPC. Let's create the cluster, and within few minutes you will be seeing like the cluster coming up for us with the basic information what we provided on the screen. So as I said earlier, you first need to have a cluster, then you will be defining your task, what needs to be run in that cluster, and then you will be. So if you see in my case, I got a cluster with this name Docker Penang demo, and if you see there would be a ECS instance which will be spinning up soon for you. Let's give it some time. If I had to go to my EC2 console, so if you see there is a new EC2 instance which got spinned up for this cluster which we created on our end. And if I refresh the page, you can see the same EC2 instance associated with this cluster. So basically, when I created my cluster, I said that I want one single instance of EC2 instance of the type instance type M5 and large. So it created a EC2 instance for me, which has Docker installed on it. Now our second step is to create a new task definition. So in this case, I know my cluster is using EC2 instance type. So we will select the launch type as EC2. Switch to that and let's give a name task Docker Penang. I'm using the default roles what I have, leaving it for the default mode. So that's let's say if there is a workload which has multiple containers running it, and your container needs to talk to each other. So that's the network mode which helps to make the communication between different containers happen successfully. Uh, I'll take the default role, task execution role. So task memory, let's say I want to give it 1 GB, and task CPU, let's say I will give it a full CPU unit 1024. And now it's asking us for add a container for this. So Docker Penang demo, and we'll use the basic Nginx image from the Docker Hub. Let's say you want to put a enforced memory limit. You can set your hard limit. So let's say if I specify it as 500 MB, and with this rule enforced over here, what it will do is that it will make sure if your container goes and consume anything greater than 500 MB of memory, it will kill and it will spin up a new instance for you. So in our case, I will leave it blank, and I know the Nginx container runs on 80 port, so I will map the port. Let's leave all the default values. So there are many other informations which you can make use of. We are not going to use those for this demo purpose. And that's my container definition. If there is a need to attach any volumes, you can do that one also by adding volumes over here. So let's create the task definition. So that definition is created. And if you see the JSON, that's something what I showed you on my screen earlier. This is how the JSON looks like. So basically you used the AWS console to create the task definition. If you have an experience with the Amazon ECS service, you can manually basically generate the JSON also. Now, once I have this task definition, what I can do is that go to my service, and so there are two options. Either you can run a task manually, which is like executing the Docker run command, or in case you want to have a high control on the container which is being getting spinned up, so that if something bad happens to that container, Amazon ECS being using a service definition, make sure that you have particular instance of container running every time. So let's see how that's done. So my launch type I know is EC2. We'll take task Docker Penang. We'll use the cluster Docker Penang EC2. Next demo. The service type, replica. So how many numbers of containers do you want for the same task definition? That's specifically you can specify in terms of number of containers, or let's say there is a need to run a single copy of container on all the nodes that are participating in your cluster. So in that case, you will make use of the daemon. So in our case, I will make sure that I have one task and the deployment options. So that's where Amazon ECS helps you to do kind of different deployment options. So we will be using the rolling update one. So if you look at the options, it helps you to basically bring down the existing running containers in a manner which would not uh, disrupt your services that have been running in your environment. And then the other option is blue green. So let's say I have a new image that needs to be deployed to this cluster. So I can divert my traffic partially to one of the new image which is being deployed. And rather than taking down the whole environment, we can like partially move some of the traffic to the new image. And later on, if we are satisfied with it, we can like switch back to the latest image. So those are the different deployment options available for you. Then there are the placement templates. So each ECS, when it comes up, it gives you to spin up your workloads in different availability zones. So that's where it's asking for different placement options. Let's skip all those default values. Now we can associate a load balancer for our service. In our case, we are going to use application load balancer. There are the different options for network load balancer and classic load balancer also. So in this case, let's use the default role. So for the demo purpose, I have already created. If you want, you can go and create a new load balancer also. And I know the load balancing has to be done. So anything traffic that comes, uh, I need to map it to the port 80 of the service, which will be routed to each particular EC2 instance. Okay. Yeah. So basically, I'm adding this rule to my existing load balancer. So I'm saying that any traffic that comes for port 80, route it to my target group, which is basically the target group which has my EC2 instance. And so click on the next. And then it also gives you the option to scale your services automatically, uh, depending on some of the conditions which you can monitor and set the auto scaling accordingly. But for this demo purpose, we are just using the first option where I'm not using any auto scaling feature. So once that's done, let the service being created. So what it will do is that it's basically creating a container instance which will be run on my EC2 instance associated with this cluster. And it's created a load balancer behind which your container is being run. And if I go to my load balancers, if you see, uh, and if I access this, I should see my service come up. So basically, if I access the DNS name for the load balancer, you see the service is being routed to my EC2 instance. So when I hit the DNS name for the load balancer, it gave me the default Nginx page, which is basically served for you from this EC2 instance, which is running your container workload. So in my cluster, I have my service, which is named as Nginx demo, which has my ECS instance, which is this one, and it's running my container workload. So that's how you would do it manually from the AWS console. So let's switch to my slides. Yeah. So in the demo, what we saw is that basically to have a container workload run in using the Amazon ECS service, basically you need to create a VPC. Then we defined our cluster. We defined our task definition, how the container would be running, which image to be used, and then basically we created a ECS service which runs your container workload, creating a load balancer. And if you had noticed, I was using certain AWS roles. So those are the IAM roles which were created before the demo. And then I was using some of the security groups and log groups, which so basically to just run a simple Nginx container, you need to have all these resources set up on your AWS console manually. But what if all these resources are created automatically for you? And that too, using the same experience what we have working within the Docker CLI. So all this is possible now if you are using the latest Docker desktop version. So starting from the stable release of 2.3 and on the edge release of 2.3.2.0, the Docker desktop has a new feature which enables you to basically run your container workloads, staying on the same CLI and pushing your Docker workloads to either Azure or AWS. So in this demo, we will be basically focusing on Amazon ECS, how those features are implemented. So the prerequisites for you to have this setup on your machine is that you would have to, if you, uh, based on your operating system, you need to have a latest stable or edge release of the Docker desktop. And all those features which you see integrated with your Docker desktop is because of the reason that Docker did open source the Docker Compose specification back in July, something I think so, where all the major cloud providers joined the open source project, and Azure, Microsoft and Amazon were some of the early adopters of it, and they have made sure that staying within the Docker CLI, you can deploy your containerized workloads to specific cloud. You can read more about the project over here uh, on the Docker Compose CLI open source GitHub repository. So I have everything set up on my machine. So let's walk through a demo of how that would be working from your desktop. So what I've done is that I have basically cloned a project which I will be sharing with you after this talk. Uh, and it's basically a simple Python Flask application, which basically talks to a Redis container. So it has a basically a simple UI where it generates a timestamp on the UI. with every refresh of the page, and it's writes the same value to the Redis container. So if you were starting with the development, and once you have developed your code base, the first thing to Dockerize is you would be writing your Docker file so that you can turn your app into a Docker image. So that's basically the basic step you would start with. So I have the Docker file for it, and I have a Docker image generated out of it. And as this is multi-service, or I would say multi-containers based applications, if you see there is a front end, which is basically building your Docker image by the name this one, using the folder called app as the source of source code repository. And then I'm using the backend. Basically, it's the image which is available on Docker Hub. So there are two services within this one. And if I had to do something on my machine to run this as so what I will do is that I will do just use the Docker Compose tool, which is integrated into the Docker CLI by default with your Docker desktop installation, and you would just do Docker Compose up. So in my case, on my local system, if you see now, I have the app running on my machine, and every time I hit the timestamp, it's basically rendering the UI and writing the values for the timestamp into the Redis container. So you as a developer, you have done your development, everything is working fine for you. And what the next step would be, you need to deploy this into AWS, especially using the Amazon ECS feature service. So to do that, the first thing is you need to have the AWS CLI installed on your machine, which would basically give you uh, a way to talk to your AWS account. So in my case, I have configured my credentials and it's pointing to my AWS account, which I had showed you in the demo, basically this one. So whatever commands what I'm executing right now, it's being executed locally. So the first step is I need to make my Docker CLI talk to the Amazon ECS service. So there is something called Docker context. So context is basically pointing your Docker CLI to a Docker engine where all your commands get executed. So if I do a Docker context ls on my screen, so Docker context by default, when you do your Docker desktop installation, there would be only one context, that is your local one. Now, if I had to create a new context, I would be using a command called something called Docker context create ECS Docker Penang demo. So basically, you are telling that please create a context with the service ECS and name it as Docker Penang demo. So by reading your AWS credentials files, which is stored with your AWS CLI installation, it will ask you basically a few questions. It's in my case, it's asking me the profile name. So I can give it test profile. Uh, it's then asking me for region. So I can give it as AP Southeast 1, So that value comes from the region where you are trying to do your deployment. So in my case, if trying to do the deployment in Singapore region, and the value is AP Southeast 1. It's enter your credentials. I have already entered my credentials. So now if I do a Docker context ls, you would see Docker Penang demo which got created, and it's pointing to the region AP Southeast 1. Uh, So if I had to switch to the one which I have created, I would do a Docker context use, and I will use a profile which I created early, context which I created early. So now if I do Docker context ls, if you see the star, it got switched from the default to the AWS Docker. Now, if you execute the same commands against the context which is set as AWS Docker, it would give you some error saying that command image is not available in the current context AWS, because now your Docker CLI is talking to the Amazon ECS service. So basically, it doesn't know how to execute this command. But if you do something like this, default context equals to default. So then by explicitly passing the context as a parameter, I can execute the same command again. So that command got executed by my Docker CLI talking to my Docker engine, which is running on my machine. So you have your context created, and you told your Docker CLI that whatever commands I execute now, please execute it against the AWS context. So that's where my context is pointing. So you as a developer, all you know is that I should be able to bring up my application using Docker Compose up. But in my case, if I had to switch to my Docker Compose file, uh, certain features like which you use locally, in my case, if you see there was a build parameter. So those kind of features are not supported by the Docker Compose on with the context being used against the cloud. So you would have to modify a little bit. For the demo purpose, what I did is that I removed the build feature within the Compose and just using a static image, which I have already pushed to Docker Hub. So I'm referencing the same image which I developed on my machine, and I had pushed it to Docker Hub. So this can be any registry, public registry where the Amazon ECS service can talk to and pull down that image. Let's say in some cases you want to make your registry private. In that case, you can create a special secret using the secret manager feature in AWS, and you can store your Docker Hub authentication as a secret and pass it in the compose file definition as this one, x AWS full credential. So basically, it will go and read the value for the secret which is stored in your account and use that to pull down if this image was a private one. Let me switch to my terminal. And basically, what I will do is that the first command I executed on my screen to bring up the application was Docker Compose up. But when you switch your context to AWS or Azure, you need to make sure that you are not using the old CLI, because we are using the new spec for the Docker Compose, and it is a standalone command now. So Docker Compose up, and minus F, the file name which I was using, especially for the ECS deployment. So copy path, and I can use this specific. So if I hit that file, it should get start with some of the deployment. So yeah, somehow it got delayed. So, but what it's doing is that it started deploying my container workloads, basically two set of containers defined in my Docker Compose file. So you will see two services getting spinned up. And if you see the first line in this, it's creating a cluster with a name called demo app. So basically, whatever the folder name is where your Docker Compose file is sitting, the root directory for that will be used as the name for your cluster. You can override that one something by using hyphen hyphen project by passing the project name to it. So whatever I showed you on my screen previously, like all these steps, what you did manually on the AWS console, it's being executed for you from the CLI itself. So creating the cluster, the VPC, the load balancer, uh, whatever task we saw earlier is being created for you automatically within from the Docker CLI experience what you had or you've been working with for the past few years. Like when it so this tool comes in handy when let's say you are a new developer who are trying to learn the AWS piece. Something got deleted. So if let's say you are starting your AWS journey recently and you are well versed with the Docker, but AWS is something new. But so staying with the same Docker CLI experience, you can try to use the same commands and try to deploy the cluster from the Docker CLI itself. So rather than going into the AWS console and creating it manually every time. Uh, if it's backend service, I don't know, for some reason, it is deleting in progress. Let's give it one more time. Mhm. Let's check on the AWS console. Did it create anything or not? No, that is weird. Um, let's check what happened. So while that comes up or it gets cleaned up, let me check if there is any question. So there is a question from Sai. Would you agree that Docker on Windows has some disadvantages over Linux or Darwin? So I wouldn't say uh, disadvantages. Basically, it's the way which the Docker images for Windows or Docker containers on Windows behaves different than on running on Linux or Mac, what you're seeing on my screen. Uh, cannot pull container error. It resolve this. Yes. Let me just try to do a comment. So, Simon, to answer your question, other thing is that most of the Windows container, if you're trying to run a web application, it uses IIS as the base image. So, which basically is, if you compare the Docker image sizes with the Linux images, rather where you're using Nginx or other to run your just basic web application. Yes, in terms of image size, it does makes a difference, and the startup in that case is a little bit slow. But I wouldn't say it's kind of a disadvantage. That's how the Windows images are built. And if you know, with the latest Windows Home Edition and the latest Windows 10, you can make use of the Windows subsystem for Linux feature, WSL2 features, and you can basically run Linux containers side by side on the same Windows desktop what you're using. So maybe try to switch to WSL2. That would help you in some way. I've not played around with most of the WSL2 features, but what I heard from other community members is that the Windows development experience has got better with those WSL2 features being implemented, especially integrated with Docker Desktop. So if you have seen this one in the Windows, you would see some features which would show you the WSL2 integration within some pages like this one. So you can go and enable. So basically, rather than running a full VM, which was the case when you used Windows 10 earlier, so for Linux containers, there was a full-blown VM which we used to run. Now with the WSL2 features, it's not the case. So it's very lightweight and you have a full Linux kernel running on top of your Windows side by side. So I just basically executed the same command and I hope this time I get a success and I see everything being created successfully. Let's give it some time and you would see the service come up. So let's switch to my AWS console. And if you would see, it created a cluster for me. Now, if I go into this cluster, if you see my properties for the cluster, it is of the launch type Fargate. The reason it's using Fargate is because the Docker Compose CLI tool integration right now, what you saw with ECS, has support only for Fargate as of now because it's being currently under development. For the EC2 launch type, it would be released. It's under active development. I don't have an exact date when that will be released, but as of now, Fargate is the only launch type which gets supported with this deployment. Um, it's almost complete. So one other difference I want to show you is that, let me open up the cluster page side by side. So in this case, if you see, there are no ECS instance because it's a Fargate launch type. So the underlying infrastructure is managed for you by AWS. While when I created a cluster which was using the EC2 launch type, uh, there was EC2 instances running in your cluster. So that's one of the great advantage, I would say. You don't have to maintain your infrastructure for it. So AWS would take care of it when you're using the Fargate launch type. And if you see, the cluster creation has complete. So basically all the steps which I showed you on the AWS console manually, they're executed automatically for you. Now, if I do a Docker Compose PS, it would give you the whole DNS name for your load balancer, which is being configured for this particular deployment. And if you go and hit that URL, you would see the same application now running on top of Amazon ECS using the Fargate launch type. And that's working perfectly for you. So if you see, I didn't go into the AWS console. I didn't do any setup for my ECS cluster to come up. All I did is that I just used the command docker compose up and just pass the Docker Compose file, which I want to use for my ECS deployment, and it magically created the underlying resources required for my container workload to run. Now it has some cool other features if you see. So if I do a Docker Compose and let's say this feature, Docker Compose convert. So the command Docker Compose convert, what it does is that basically spits out the CloudFormation template, which is being used underneath this. So behind the scene, when I executed the Docker Compose up command, it basically took my compose file using the compose specification. It converted into a CloudFormation stack, which basically is the deployment template for your ECS deployment in AWS. That's basically the template which AWS understands. So that under the hood was converted for you and executed against your AWS account using the same command. But if there is a need, let's say I want to store this template in CloudFormation template, which is generated for this particular deployment. So I can go and save it, and maybe I can pass this to my infrastructure team to do the deployment in other environment where I need to set it up. Or let's say I can use this as a auto base starting type for setting up my automation. So that's Docker Compose command which you can use. And the other thing is, if you see Docker Compose logs, so you can see all the logs streaming up on your console, which is basically getting streamed from the AWS. So if I had to show you live, so if I hit this, you should see the log streaming up on my screen. And let's switch to my AWS console. We can go and search for CloudWatch. So As I said previously, it has integration with other AWS services. So I am watching the CloudWatch service where basically it configured a container inside. And if you see, I can go and look into my nice little dashboard, which can be used for your monitoring purposes also, and can have a high overview how your workloads are behaving and how the resource utilization is being done for you. Um, the other is log groups, which I wanted to show you. So by default, when you spin up any workload using the Docker Compose command, it will create a log group with the same cluster name what was used. So Docker Compose slash doc demo app is your log group which got created. And the logs which you saw on my screen, you can see the same being saved on the AWS side. So if I have to do this one, and I go and hit some actions over here, you will see those coming up at the end for you. So that's how. So within a single command, you see it set up the infrastructure for us. It set up the log in mechanism. It set up a monitoring kind of environment for you. So all that was done basically using a single command, that is Docker Compose up. Now at the end, if you want to bring it down, all you want to do is that Docker Compose down, and it will tear down your cluster for you. So it would start deleting the resources which got spinned up using that up command which you executed. So within staying within the CLI and using the same experience what you had with your Docker development, you were able to spin up a ECS cluster. So that's the new features which got rolled out with the Docker Desktop. If I to show you the GitHub project for this, let me switch to Docker Compose ECS. So we have a nice documentation around this, basically for both the cloud. Whatever we saw today, if you have any doubt, you can start your exploration by going to this URL. Let me put that in the chat for you. So it has various more features. So what I showed during my demo is just a basic feature to spin up the containers. And if you look at the project, this is where the code base for this resides, the Docker Compose specification. And it has basically a simple example of how to deploy is your workload into ECS and ACI both. Uh, Other place you would refer is if you go to the docs and you have some basic examples of ECS, how you can configure more in depth. So this is how a service can be bind, and using the various Docker Compose specifications, the features which are available within Docker Compose can be used within your service definition. So earlier I showed you to put resource values which will be used, so that can be specified within your service definition also, like something like this. This is how you would set up your logging. So right now when I did spin up the ECS cluster, it did all the work for me. So let's say there is already a log group which is being used in your environment. You can use existing log groups also. So if you look into this documentation, I can paste it in the chat for you. It has reference to many of the examples, how to spin up various services and what parameters are available right now. So please do explore those things. And if you have any doubts, do reach out to me. Happy to help you at any time. So as part of the demo, that's what I had. And I will be sharing all the source code and the slide deck, what we saw here, to all the members who got signed up. And there would be a GitHub repository where I'll be uploading this. I will share those information with you all. So uh, I'll be happy to take any questions if you have. Please do post it on the chat. Do join our Docker Slack so you can talk to other community members. You can I can share you the URL for that. Slack dot. Here's the link for the chat for you people to join our bigger audience in the Slack channels, what we have for community members. Any AWS specific access right need granted for user able to use local CLI to deploy ECS from local? Yes. So basically, the user should have. So it depends on the launch type. So if it's using EC2, so basically all the rules to create EC2 instance type, all the permissions around it. And then if it's a Fargate, I would say there is a policy which is specific to ECS. I can show you that on my screen, how it looks. Let me check that I have my login. So in my case, if you see on my screen, this was the user I was using to deploy my workloads, and I have custom policies attached to this IAM user. And basically, if you look at this, uh, it has certain EC2 roles, actions allowed to it, which is basically the EC2 launch type. But in my case, I have given all the ECR related permissions to the user. So yes, if you had to cut down that specific, you can go and to play around with this policy definition, what you see. So basically, you would start with basic EC2 and ECR launch types permissions, which are required. And then there are certain roles which were used during the deployment. So you would have to play around with. Maybe I can put it on the GitHub repo, which I will share with you all, and cut it down to the least permission that would be required to make this deployment happen for you. Hope so that answers your question. Any more questions? So I don't see any questions coming up. If you do have, you can reach me out on Twitter, which is in the chat. That's my Twitter handle. And or you can reach me out on the Docker community channel. So thanks everyone who attended the session. I'll be shortly sharing you all the slide deck and the GitHub repo which were used for this demo. Thanks. See you next time. Bye. Take care.